Audio reactivity and control of parameters has obvious uses within the entertainment industry and is becoming something that's more widely accepted. Using audio to control any of your parameters in AI and in the Salvation engine can be relatively easy once you've done the initial setup and can be used to drive almost anything in the system. So first of all, let's get our audio input module in there. So in the import section, we've got live audio is the module, so we're going to just add that one in. We've got a few ports on here, but it's not too much to deal with at all, so let's get some things in there. Now we're mainly going to use constant faders. You can use any control that you want on that, but I find that the horizontal fader works quite nicely with this one. I'm just going to duplicate that up a few times because I know I need a few different instances of it. Okay, cool, and we can also see that we've got a yellow output there, a window output. So let's connect our window there, turn the window on, and we're not seeing anything at the moment because the module is not yet enabled. We shall get there in a moment. I'm just going to open this one up a little bit because we're going to see something quite nice and visual in a moment. Okay, so now let's just start to get things actually connected up. So peak fall speed, so this controls how quickly the waveform will drop after the signal has been received. The minimum amplitude and the maximum amplitude determine the required amplitude for the signal to be read. The frequency minimum and maximum specifies the range of audio frequency that we are analysing at that moment in time. The number of bars slider literally will change how many divisions we have in our FFT audio analysis. And then last but not least, we have a colour input at the bottom. So let's just throw a colour swatch on there and put some control in. We'll put the one up a bit as well. Okay, cool. So now we're all ready and set up. Let's just get rid of those couple there. Let's just look at how the module works, and then I'll just show you a couple of ways that we can take data out of it and use them to our advantage. So, first of all, we can choose whether we're using stereo or whether it's just mono, using just the left or the right channel. The display mode we'll see in a moment when it's actually functioning, and it's how this is visualized on the output. And of course, we've got our device that we're going to listen to. So hopefully this is going to listen to my laptop microphone when we speak. So I'm hoping that when I press enabled, we'll start to see some kind of waveform appearing here on the right. In fact, we're not going to see something straight away because all of my values are set to 0. So the first thing we do, let's put our frequency max up. Let's put our amplitude max up as well. And let's increase the number of bars that we've got there. And let's just increase the peak fall speed. There we go, so it just falls off a little bit quicker than that. Now I can see I've got some interference coming through from the computer there, so I'm just going to take the bottom end off, and maybe we'll just reduce that amount of bars a little bit so it's a little bit more easy to understand what's going on. And we'll just take our minimum amplitude down, push our maximum up a bit. There we go, let's just bring that frequency down a little bit more. Okay, so I think we can see what's going on there now. So, as you can see, we can make audio analysis quite easily. You can see it's picking up the sections of my voice there. Obviously, changing that amount of bars will change the perceived smoothness of that image. Now, we had a few different ways of looking at this, so what I'm going to do, I'm going to just slow it down as well. So we just reduce the peak fall speed again, just so that it holds that value for a little bit longer. And I'm just going to pull that value down. There we go, just so we can see that. Okay. So that's picking up quite nicely actually, you can see what's happening there. So this is on level bars. So level bars and level line, they're both solid images. Now bars obviously has, for each division it has a flat horizontal top to that bar, whereas if we go to level line, we'll get angles between those points. If I reduce it even more, you can sort of see. So there, instead of having the horizontal line, we've got a point in the middle, and it's drawing a line between those points. As well as that, we also have peak bars. So peak bars is like the bars one, so it's the horizontal line, but it's just showing the peak rather than the whole bar. And last but not least, we have peak line, and I think you can kind of guess what that one is. That will give us a more sort of traditional looking sort of audio frequency spectrum. So let's have a clap, and you can see the different components. My voice picks up this lower section here, and the clap will pick up these higher end sections, and so on. So the frequencies determined by the module are down to the card itself. So 0 to 1 of the frequency range is the minimum to the maximum frequency range of that card. Now I'll do another tutorial about converting values and stuff like that, because there are ways that it's easier to deal with it than on a slider. Okay, now obviously we can use this piece of waveform as a visual. I'm quite a sucker for a nice bit of a waveform in video. It looks quite nice and cool. Everyone knows what's going on, does the job. But there are other ways that we can actually use these values as well. So first of all, what about if I actually want to take a true number value from my FFT? So we've got this frequency level section. Now if I bring up the inspector, let's just bring that down a little bit in size, and then we click on that port. So you'll see it's presenting me with a vector there. So what we can do, we can put our vector split module on there. So that's in the math section, math vector split, like so. We can take that frequency levels, plug them into the input, and then I think what I will do here, let's just put some monitors on each. So controller monitor, so monitor just lets us see the incoming value and passes it through. And I'm literally just going to split this open to 4 monitors, and then I'm just going to actually join it together again. I'm really just putting that split in there so that you can see what's happening. Like so. And I'm going to use our old friend the rectangle to actually make this active. So obviously if this was connected to a functioning process, this would be working, but as this wasn't currently connected on a GL pipeline, I had to complete that connection. There we go. Okay. There we go. So you can see those values running in real time there, doing their thing. So we could extract those individual ones. You could send the individual components to different parts. So you can see what's going on up there at the moment. So that's a really useful tool. Now another one that I'm quite keen with using is the frequency texture module port. So let me show you what's going on there. So you'll have noticed that with vectors currently we can only access 4 places in a vector, and there are times when you want to access more than 4 components of the audio frequency. If you really do want it as part of a vector, what I would suggest is using multiple modules, offsetting those frequency bands so that they're outputting different frequencies. But this is going to be another way to do it. So we've got this frequency texture port here. So if I connect that to my rectangle and display it on the window, now initially it's kind of hard to see what's going on. Now I'm going to just expand that a little bit just to bring it up. Now what's happening with this version, I'm going to just decrease the amount of points there so that other ones increase. Cool, and let's put that back to level bars so we can see that as well. Okay, cool. So what happens with this texture port, it's presenting us a single square for each of the bands of the FFT, and rather than giving us a value, it's giving us a colour. So obviously you can see that black is a very low value and that white is a very high value. Now on its own this might not seem that useful, but actually we've got another really useful module called texture sample. There we go, down in the vision section at the bottom. Now what texture sample can do, texture sample can create samples from a specified point. So what it will do is it will look at the specified area and convert that into a value for us. So what I'm going to do, I shouldn't have deleted my vectors just now. I'm going to use those again. So we're going to do vector join. So this is going to output up to a 4-place vector. Let's get a monitor in there as well. In fact, we don't need to. We can just control the colour of this rectangle. That'll be easier, rather than us looking at 4 separate values. So for this module to work, it needs to be connected. Then once it's connected, we'll see a sampling point. Just connect that into there. There we go. Okay, great. So there we go. Okay, cool. So let's just bring him in now. I was looking at the wrong window there. Okay, cool. So you can see this sampling point that I've defined here, and I can actually move that in real time. And then if I open my other window there, there we go, that's why it's confusing me. So you can see that this value of this rectangle, this colour value, is being controlled by this sampled point here. Now you'll notice on that texture sample module, we can actually have loads of points on this. So I'm just going to throw in another couple. As we remember, we need to have that windowed on an output. Like so. G, B. And although I'm taking all of the channels there and summing them as a total, I could actually be using single channels there. I could just use just the red channel, just the blue channel. There we go. So we've got that other point there. So I find the texture sample module is really, really useful with this frequency texture outputs, and this will allow you to go up to 500 bands of FFT, which, as far as I'm concerned, is more than enough frequencies of control for an incoming audio signal.